We're just gonna start now. Same person stuck in the reading room. But we're gonna go over USACO, the January 2017 contest. So that's like it's been a while ago, but we're going over it. We're just we just chose this one. Anyways, but first, before we start, some general announcements. So I'm unsure of how many of you guys know, but the Google Code Jam is this Friday. It's from 3:26, which is a Friday, from 6 a.m. to 3:27, or Saturday at 12 p.m. It's a 30-hour window. Basically, you can find more information here. You can see the qualification round is in 1 day, 17 hours. Basically, what it is it's a global coding competition, and then it's a bunch of like algorithm puzzles. Basically, it's kind of similar to like the USACO questions, though the difficulty is different, obviously. And then you can make it really far and you can win up to like $15,000 or something. However, I'm pretty sure you're also going against like not only high schoolers, so it's like much more competitive. But the schedule, the way it works is that there's a qualification round. It's 30 hours. You don't need the 30 hours to qualify. There's like a point minimum, and once you reach that minimum, you're like qualified, and you can just kind of like head out, and you don't have to finish like all 30 hours. And you can like I think you can choose to start anytime between these start and end dates. And then assuming you qualify, right? There are like upcoming rounds, round 1A, 1B, 1C, blah, blah, blah. And if you keep on going and you keep on qualifying round after round, in the future, you might make it to Worlds Finals. So if you guys are interested on the Code Jam, I'm gonna link this. I'll link into the chat. And then also on Friday, like probably during first period after it started, we'll send an announcement with some more information about it. But yeah, basically, this is the most important thing you just need to know. The qualification rounds on Friday, and I'm pretty sure there is no like other qualification round. So if you are interested in this, you should probably try to clear some time this weekend, this Friday, Saturday to attempt the qualification round. Otherwise, other things are USACO US Open. That's on the 2nd to the 5th on April. That's during spring break. We have no meeting on the 7th because of spring break, and our last meeting is on the 14th, the week after spring break is over, where we'll be going over the US Open that happened on the 2nd and 5th. Anyway, so I'm going to start with the 2017 contest. So we're going to be looking at bronze problem number 2. Um, this is what it looks like. I'll send the link. But I'm gonna read it really quickly and then I'm gonna summarize basically what it's asking. But it says, you have probably heard of the game rock, paper, scissors. These cows like to play a similar game. They call it hoof, paper, scissors. The rules of hoof, paper, scissors are simple. Two cows play against each other. They both count to three and then each simultaneously make a gesture that represents either a hoof, a piece of paper, or a pair of scissors. Hoof beats scissors, scissors beats paper, and paper beats hoof. And for example, if the first cow makes a hoof gesture and the second a paper gesture, then the second cow wins. Of course, it is also possible to tie if both cows make the same gesture. So basically, in case you didn't get it yet, it's just rock, paper, scissors, the same exact thing, except replace rock with hoof. And that's what the game is. Also, I'm going to be referring to hoof, paper, scissors as like HPS a lot because it's kind of long. And then Farmer John is FJ. So FJ watches in fascination as two of his cows play a series of N games of HPS, with N being up to 100. So N isn't that big, which is pretty good. And then unfortunately, while he can see that the cows are making three distinct type of gestures, he cannot tell which one represents H, which one represents P, and which one represents S. So to Farmer John's untrained eye, there all seem to be variations on hoof. So not knowing the meaning of the three gestures, FJ assigns them numbers 1, 2, and 3. So perhaps 1 stands for H or it stands for P. Meaning is not clear to him. Given the gestures made by both cows over all N games, please help FJ determine the maximum possible number of games the first cow could have possibly won, given an appropriate mapping between numbers and the respective gestures. And an input format, first line is N, right? So in this case, it's 5 games. Each of the remaining n lines or 5 lines contains 2 integers, each 1, 2, or 3, describing a game from FJ's perspective. And then we want to output the maximum number of games the first of the 2 cows could possibly have won. So in our sample input, we have 5, then 1, 2, 2, 2, 1, 3, 1, 1, 3, 2. And so the sample output is 2, because one solution of several for this sample case is to have 1 represent scissors and 2 represent hoof and 3 represent paper. And this assignment gives 2 victories to the first cow, right? 1 beats 3 and 3 beats 2, right? Scissors beats paper, and then paper beats hoof. And so that way cow 1 would win twice and your output would be 2. And no other assignment of 1, 2, and 3 leads to more victories. Yeah, so that's the problem statement. Um, Basically, this is it summarized in a nutshell. Paper beats hoof, scissors beats paper, hoof beats scissors. 1, 2, 3 are assigned to 3 random H or P or S. N is only 100, which is very doable. And you want to output the max games that cow 1 can win. So, given all this stuff, the first thing that like comes to mind is to just like brute force it, right? Just try every possibility for 1, 2, and 3, like 1 being paper, 2 being scissors, whatever. And if you do that, you only have to try like 6 possibilities, I think, because 3 times 2 times 1. But that's not like the best way. There are much better ways. And so we're going to be looking at those other ways. However, if you're in a contest and that's the first thing you think of, you can probably just code it up and it should probably work because N is only 100. But the first thing to notice is that 1, 2, 3 are assigned to random numbers, right? And each game you're given 2 different numbers or two numbers. They could be the same. And you have 3 outputs. It's win, lose, or tie. And there are no other options, right? And if the output is a tie, that meant we don't care what the numbers actually are, right? Because a tie just means the 2 numbers are the same. So if the 2 numbers, if it's a tie, we don't have to worry about it, right? As long as the 2 numbers are the same, we don't have to worry about the assignment. In any assignment, in any of the 6 combinations of assigning 1, 2, and 3 to HPS, um, it's not going to like differ if it ties because it's just the same number. But if it doesn't tie, that means either cow 1 or cow 2 wins, right? Or either cow 1 or either cow 1 wins or cow 1 loses. And so we want to max the cow 1 wins. So hopefully you can see that like cow 1 and cow 2 are interchangeable at the end, because if we think about it in this scenario, so let's assume 1 beats 2, 2 beats 3, and 3 beats 1. And then given some sort of series, cow 2 has more wins, right? If that's the scenario, we can just flip it and inverse everything. So instead of 1 beating 2, 2 beats 1, 3 beats 2, and 1 beats 3. And this time, cow 1 would have more wins, and specifically, it would have that number of wins that cow 2 had. So therefore, given that, we can just output the max wins of either cow 1 or cow 2, because at the end, it doesn't really matter if cow 1 or cow 2 has more wins, because we could have just reversed it if cow 2 had more wins and cow 1 would have had that many wins. And so it also doesn't matter what 1, 2, 3 are and what we assign them to, because um, and I can explain what I mean by that, because it might be a bit confusing. But if we look at the scenario, right, with 1 being scissors, 2 being hoof, and 3 being paper, let's assume we choose like a different scenario of these 3 assignments. So instead of 1 being S and 2 being H and 3 being P, we shift everything to the right. So 1 represents H, 2 represents P, and then 3 represents S. So if we try that, we're gonna get the same thing, right? So 1 and 2, 1 was hoof, 3 was scissor. Well, 1 was hoof, 2 was scissors, and wait, 1 was hoof, 2 was no, 1 was hoof, 2 was paper. Sorry. And so in this case, cow 1 would lose, and cow 2 would win this game. 2, 2 is a tie. We don't care. 1 and 3, cow 1 would still win, right? 1 is hoof, and 3 is scissors. Hoof beats scissors. Cow 1 wins that. 1, 1 is a tie. 3, 2, cow 1 also wins because 3 represents scissors and then 2 represents paper. Scissors beats paper, right? So cow 1 wins the same games. Cow 1 wins 1, 3, and 3, 2, like it did here. So basically, if you shift everything over, it's still gonna have the same theme because it's going in a circle. 1 is beating 2, then 2 is beating 3, then 3 is beating 1, or vice versa. But then if you wanna like test flip-flopping, right? So let's keep 2 representing H. So 2 is going to stay as H. This time we'll switch 3 and 1. So 1 is going to become P and 3 is going to become S. 2 is going to stay the same. So now 1 versus 2, 1, which is P, and 2, which is Hoof, right? 2 is H. 1 wins. So Cal 1 wins this first game this time, right? It's different. Cal 1 wins. And then it's a tie. No one cares. And then 1 and 3, this time 1 represents paper and 3 represents scissors. So Cal 1 loses. And then 1-1 is a tie. And then 3-2, Cal 1 also loses, right? Because 3 is scissors and 2 is hoof, and scissors loses to hoof. So Cal 1 loses. And so what we have here, right, in this scenario when 1-3 are flip-flopped, we have Cal 1 losing these 2 games, which I previously won, and instead it only won this 1 game. So Cal 1 only won the first game, and Cal 2 won the next 2 games, excluding the ties. And basically, remember, we mentioned here that we can just output the max wins. And if we just output the max wins, it doesn't matter because Cal 2 is 2 and we're still going to output 2 because that's the max. Basically, if you like flip it instead of shifting it to the right or left, it's just going to flip the wins, the max wins for Cal 1 or Cal 2. So in that scenario, it's still taken care of because we just output the max. And so that's basically how it works. So I'm gonna pull it up the solution from scratch right now. Oh, I didn't mean to do that. Um, so caught HPS bronze, the Java. So first input regular statements, and then note that this problem is like an ode problem, so we have to use file readers. We cannot just use the system.in and system.out, which we're like kind of used to using. We have to use file readers, but that should be fine. I'm throwing the IO exception because we're going to use a file reader. So basically, we'll just use a scanner because it's simple. And then we'll have the new file. The file is hps.in. Hps.in was given to us in the problem statement. Um, and then the output, which we're going to use a print writer, is going to be the same thing. Um, print writer, new file writer, new file, hps.out, right? And hps.out is also given to us. And then so we first want to grab n. So grabbing n, int n is equal to in dot next int. So that's very simple. Now we want to keep track of wins, right? So we want to keep track of the number of games that Cal 1 or Cal 2 wins. So we'll create 2 variables. Int first wins, this one's equal to uh, 0. And then int second wins is also equal to 0. And then we're going to increment them when first or second wins, right? So we can loop over as we're incrementing. So we'll create a for loop to grab the input and increment. So in the for loop, each game, right, n games, we're going to first grab the cow on the left, the cow one's gesture, right, 1, 2, or 3, and we'll grab cow two's gesture. So we'll call them first and second. And then we just need to do some if statements, right? So we first test if it's a tie, because if it's a tie, we can just move on. So if first is equal to second, we can do continue, right? Which is continues the loop. So it just skips everything below this and just goes to the next I plus plus. And then if it's not, I'm just putting an else statement for like better readability, but you actually don't need an else statement. You can just like, because it's gonna continue anyways. So we want to check which games that second cow would win. So if first is equal to 1 and second is equal to 2, we're going to let cow 1 win this. Second wins. Basically, we're going to pretend 1 is equal to hoof and 2 is equal to paper and 3 is equal to scissors. That's like our pretend assignment. We've already proven that it doesn't matter what 1, 2, and 3 are assigned to, but it's just easier for us to like think about it. So else if first is equal to 2 and second is equal to 3, right? 3 is greater than 2, 3 beats 2. So we'll also increment second wins. And yes, you can combine all of this into one if statement, but once again, I'm just doing this for better readability. And in the last scenario where second would win, cow2 would win is if first is equal to 3 and second is equal to 1. And then we do the same thing, we increment second wins. And then the last one is just an else. We're going to increment first wins because we first check the possibilities of second cow2 winning. And if none of these get triggered, then that means cow1 won because there's no case for it to be a tie because we already checked that already up here, right? And then so after that, we can just use our print writer, which is called out, and we're gonna print the max of cow1 and cow2 are their wins, right? So max of first wins and max of second wins. And then we gotta close our print writer, otherwise it won't work, and that should be it. So I guess I can submit it right now, and we can hope that it works. If it doesn't work, it'll be kind of sad. Let me log in first. Okay, so I've logged in. We'll try it. It should work though because I tried it before. Okay, yeah, so it does work. There's one more test case, so we'll wait for it. All right, so it's 10. And then really quickly before I move on to the next question, I want to show the USACO solution, which actually I thought was pretty interesting. Basically, they have the same theory and stuff, but instead of per se looping and counting and checking if one is greater than two every single time, um, they actually stored in a 2D array. So what they did was they initialized an array of matches is 4, 4. Basically, so it's hard to explain, but you can think about it as if assuming you're given the input like 1, 2, right? So cow1 gave the gesture 1 and cow2 gave the gesture 2, then we would increment matches of 1, 2, right? So this 2D array, we would increment that little element, that little box right there. Just think of it like a grid, right? Just think of it as a 3 by 3 grid with the first column and first row like removed because it's uh it's a 1D like it starts at 1 instead of 0 because the gestures start at 1 2 3 not 0 1 2, and then you increment the plus plus each time, and then you just check the maximum wins of 1 2 2 3 and 3 1. So it's really hard to explain, and we don't have time to explain it. But their way is technically better. I think both of our solutions are like O of n or something, but theirs is only technically only checking one if statement at the bottom. We're checking an if statement n times inside a loop, so it's like a minor thing. If we have time at the end, I will come back and pull open a Google spreadsheet and show like how it works. But we're just gonna move on now. I want to go over the next question, which is silver number 2, hoof, paper, scissors. Um, so basically, this is the reason why we chose the 2017 January contest because it's the same problem statement basically. We do not need to read any of this. It's identical. What we do need to read is this paragraph, right? So given the hoof, paper, scissors game, FJ wants to play against his prize Cal Bessie N games of HPS, and it's 100,000. It's much bigger, but at the same time, 100,000 is still doable. Bessie is an expert and can predict each of FJ's gestures before he makes it. So, AKA, basically, we are given FJ's gestures, right? That's predicting technically. But unfortunately, Bessie is also very lazy because she's a cow. So, as a result, she tends to play the same gesture multiple times in a row. In fact, she is only willing to switch gestures at most once over the entire set of games. So, for example, she might play hoof in the first X games, then switch to paper for the remaining N minus X games. So, given the sequence of gestures FJ will be playing, please determine the maximum number of games that Bessie can win. Input format N, and then the gestures P, H, or S, or HP or S by FJ. And it outputs how the maximum number of games Bessie can win, given that she can only change gestures at most once. So the reason why the sample is 4, because if you think about it, the first 4 games, Bessie just plays scissors and beats FJ 3 out of 4 times. And in the last game, Bessie switches and plays Hoof and beats FJ the last game. So she wins 4 for 5 games. So yeah, this problem is also, it's very interesting. But basically, this is the problem statement simplified. Paper beats hoof, scissors beats paper, hoof beats scissors. N is 100,000. It's doable. We do know FJ's move, but we can switch only once. And we want to output the max games Bessie can win. So the first thing you might think of once again is just a brute force and try every single possibility. So like try every single um uh, number between 0 to n and check if Bessie switches off at this point, how many games can she win? That is very doable, except you still need to figure out like the max for each between the switches, right? So like if Bessie should be playing HP or S before the switch, and if she should be playing HP and S after the switch. And then there's also one edge case that we need to bring up. Um, if FJ plays the same combination for all of the games, so let's assume FJ played P for all 5 games, Bessie does not want to switch. Instead, she wants to play the counter to P, which would be scissors all 5 games, and she does not want to switch. And we are allowed to do that because it says Bessie can only change gestures at most once. So she doesn't have to change it if it benefits her by not changing it. So that's a edge case that should be pretty easy to implement though. So basically the analysis is first important is that there's no penalty for losing. So what that means is instead of having 3 options, win, lose, tie, we only have 2 options. We either win or we don't win. We do not care about ties or losses. It's like the same thing to us. So given that it's only win or don't win, we want to max the games won. So therefore, right, we want to look for H, P, and S in high quantity. We want to find like as many H's, P's, or S, preferably in a row, and that way it's easier, for Bessie to just play the opposite of whichever HP or S it is, right? For that like stretch of games. And we can do this by using prefix sums. Prefix sums are very common, like it's not an algorithm. Is it an algorithm? Well, it's a common topic that appears in USACO, especially in Silver. And it's pretty useful. So stop at a Wikipedia. Basically, prefix sums is a second array that is the sum of all numbers of the first array at I. So if you think about it, this is the first array, 1, 2, 3, 4, 5, 6. And then our prefix sums array would be 1, 3, 6, 10, 15, 21, because at this position, 1 is 1. At this position, 3 is 1 plus 2. Then this one is 6 is 1 plus 2 plus 3. 10 is 1 plus 2 plus 3 plus 4, and so on, right? So you can think about it as this is 1, this is 3 is 1 plus 2, 6 is 3 plus 3, 10 is 6 plus 4, 10 plus 5, 15 plus 6. And that's like your algorithm, so and so for prefix sums. And the reason why this is useful is because um, it allows us to store the numbers quickly. Because if you think about it, when we're taking the input, we can automatically create a prefix sum array, and allows us to give the sum from like between 2 different indexes very quickly. So if you want to ask for like the sum of all numbers up to index 5, which we'll just say is this one, if you use the regular way without prefix sums, you would do 1 plus 2 plus 3 plus 4 plus 5, which takes a while, right? But if you do it with prefix sums, you just output, whatever P of 5 is, which is 15. And it also works for, let's say index isn't 0 and index is like starts at 3. So if we go 3 to 5, right? In the regular array, you would just do 3 plus 4 plus 5, which is 8 plus 5 is 3. Wait, 3 plus 4 plus 5. Oh, yikes. 7 plus 5, which is 12. Um, okay, I think I messed up something. Wait, 7 plus 12 is 12. Yeah, 7 plus 5 is 12. Right. And then in prefix sums, you can just do P of 5, which is 15, and you can subtract P of 2, which is 3. And 15 minus 3 is 12, right? Because um, the reason why we subtract P of 3 is because P of 5 is equal to sum of numbers up to 5. P of 2 is sum of numbers up to 2. And if you subtract that, all you're left with is sum of numbers from 2 to 5, excluding 2. So basically sum of numbers from 3 to 5. And so that's how you use prefix sums. I kind of messed up my explanation there, but basically that's what prefix sums are. And we can use prefix sums to create 3 different arrays storing the respective p-sums. And we loop and check the max wins at each I from I to 0 to n. So it'll make more sense when I code it. So we'll create another file called hps hps silver.java. And then I'm also going to use my template. So this is my personal template, but you guys can feel free to copy it if it's beneficial, or like base off, or like modify it to your liking. But basically for all USACO problems, especially when I practice and in contests, I first spend like the first normally 2 to 5 minutes and manually type out a template. You can't copy and paste anymore, so you have to manually type it out. But it's pretty fast to type anyways, so it is what it is. I'll explain it as I go. So in my template, first uses 2 booleans for debug and testing. I'll explain that later. And then the template also uses buffer reader and string tokenizer to create a so and so fast reader, which actually isn't any faster. It's just easier because you don't have to mess around with like a lot of buffer reader and string tokenizer like next token stuffs. So I'll explain more as I get to the actual fast reader. So basically first when I'm creating the print writer, I use a ternary operator and check if testing. So if testing is true, then I create a new print writer and it uses system.out instead of the regular one. And if testing is false, then I use a new print writer, which is our actual print writer, right? It uses new file writer, new file, hps.out. If you don't know what ternary operators are, I suggest Googling them. Basically, it's like an if statement, but like quicker to write. And so we're gonna create a static class, and it's gonna be called fast reader. And we're gonna create the constructor for our fast reader. And in our constructor, we have to use a try catch because we're gonna create a buffered reader. So you, oh, oops. I think it's a catch a file not found error. Yeah, it is. So we need to catch a file not found exception E. And if that happens, we throw E. Yeah. And inside the try, we're also going to be using another ternary operator, br equals testing, right? So if it's testing, we're going to read in from a new input string writer instead of the file. So new input string reader system.in, and otherwise we do a regular buffered reader. And the buffer reader will just read from hps.in. Okay, yeah. So this, why is it red? Oh, oops. Wait, public static class shouldn't be static. It should just be public fast reader. Is it not throw? Oh, it's e.print stack trace. So you said JavaScript. Oops. E.print stack trace. I'm also quite used to Eclipse's autofill function. So yeah. We're almost done. So then we create a public string. So if we want to grab a string, we have to check if our string tokenizer is null or if it has no more elements. If either of these are true, while these are true, we want to create a new string tokenizer. And we'll read in from br.readline. And then we'll catch a, what did I just do? Oh, and oops, that was weird. And then we'll catch an IO exception. We are running out of time though, so I I don't want to spend the whole time going over this. Okay, so I'm gonna speed it up a lot. So, and then we need to, if we want to read a next int, we'll just do integer.parse int of next. And then we'll do the same thing for doubles and longs. And then last one is for next line. So if we ever want to read in the whole line, um, we're gonna do like this. Okay, and then so that is our fast reader finished. And then last thing I do is I have a function at the end is for debug. So it's static void debug, and it takes in an object, so it's like could be anything. And if testing is true, oh wait, shoot, sorry. If debug is true, right, that's the boolean we create at the top, then we will print out object. So this way I don't have to comment out all of my debug statements. String next line. I forgot to return string. Okay, so now we can actually start doing the code stuff. We have 4 minutes. We should be able to code it up in 4 minutes. So we'll create an input statement and in this, input function, and then we'll create a public static void input. And so this is where we're gonna grab our input, right? But first we need to create some like static variables. So in the next int, we're grabbing n, right, which is the number of games. And then we're gonna create the 3 arrays to store the p sums of each respective papers, hoofs, and scissors. Okay, that's good. And then we're gonna create hoof num equals 0, paper num equals 0, and scissors num equals 0. And these 3 numbers variables are we're gonna use them to help keep track of our um, the p sum that we're working with. It's not necessary, but it is kind of useful. And then we'll have our answer and we'll update our answer later. So inside our input, we're gonna loop. So we're gonna first loop through all of n. N is a static variable, so we can access it inside here. And then we'll grab string next equals in.next, right? Because we're given FJ's string of gestures, right? HP or S. So if next dot equals H, then we're going to increment hoof num. And else if uh, next dot equals P, we're going to increment paper num. And then else it must be scissors, we're going to increment scissors num. And then after that, we're going to update our p sums array with hoofs of I equals hoof num, papers, papers of I equals paper num, and then scissors of I equals 2s's equals scissors num. And that's how the p sums work. I'll print out a debug statement if we have time. But basically, we're just keeping an array, and it's going to keep on incrementing. So it's like the sum of the numbers all the way up to it. Actually, yeah, I will debug statement all of them right now. So after our for loop, let's print the debug. Hopefully I can run this without it breaking. Okay, we can. Let's, okay. Response hps.in. I said if testing was true, apologies. Okay, now it's waiting for my input statement, right? Is it? Okay. So let's give 5 H P, 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 S. All right, and then, so that's our arrays. So our hoof array is 1, 1, 1, 1 because H is 1 at the beginning and it never gets incremented again, so it just stays 1. Our P papers array starts at 0 because it reaches 1 at index 1 because that's when the first P appears, then increments and it stays at 3 because the last one's a S. S doesn't get hit at all for the first 4, and then the last one does get hit, so it's 1. And then 8, hoof num, paper num, scissor num, that's 1 through 1. It's just the very last value, and it tracks as the value goes on. It's 110 right now. If you guys need to leave, feel free. Otherwise, I'm going to finish coding this up. It's going to take me about 5 minutes to finish it. Sorry for going a bit over time. So next thing we need to do is we need to check debug. I mean, the edge case, right? So if Farmer John decides to just give us the same like HPRS the whole time, that would mean hoof num is equal to n, right? Or paper num is equal to n, or scissors num is equal to n, right? If any of these get triggered, what that meant was Farmer John only put hoof num or only put paper num or only put scissors num because n is the number of games, and if the number of hoofs is equal to the number of games, that means they only put hoofs. And if that's the case, we're just gonna output n, right? Because we can win every single game. And then we want to close our print writer, and we're gonna do system.exit.1. I'm sorry, system.exit of 0. System.exit exits the system, exits the program. 0 means successful termination, so like it was good. And yeah, I think 1 means bad termination, like an error happened. But ours is a good termination. So if the edge case does not get hit, we want to create a loop, and we're gonna start at I because we want to check I minus 1. So that's why we're gonna start at I. And we're gonna loop through all the games, and we're gonna calculate the max wins you can win at each position I, right? So the max games I can win at position I is in big position. Just work with it. I don't know why I call it big position. I don't remember, but we're gonna do math.max of hoofs of I and math.max of papers of I, scissors of I. So what this statement is doing is we're checking the maximum of hoops of I and then the maximum of the max of papers of I and scissors of I. This is basically the way to say I want to find the max out of 3 different values, right? So I'm grabbing the maximum of hoops of I, scissors of I, and papers of I. And so that would be, so right here, right? This would be num of games won left side. So AK before we switched, right? Now we switch, and when we switch, we do, right? So we got to add on the max of hoofs, hoof num subtract of hoofs I minus 1. So this is the p sum scenes I was just talking about, right? Hoof num is the value at the very end. Minus hoofs of I minus 1 gives you the sum from I all the way to the very end of the array. And we can do that with a simple subtraction statement because we have it stored in a prefix sum. And then we're going to do the same thing. We're going to be checking the max of 3 of them. So that's why we have an extra math.max statement. And then scissors num minus scissors of I minus 1. I really should not have named it 2 S's. Okay. And then we just need to check if this is bigger than answer, right? So we just set answer to math.max of answer and big position. And then at the end, answer is going to be maxed out. And we print out answer. And so let's hope this works. Before I submit it to the grader, I make debug and testing false because I do not want any of those statements to be run, and I do not want it to be checking with the run system.in system.out. So this is silver, right? Silver. We'll choose the file, should be silver, and hopefully it'll work. All right, so it did work. So, and that's basically it. That's the end of this lesson. So you guys feel free to go. If you guys have questions, you guys can stay on now. If you want to see like the explanation to the bronze, their answer solution, I can explain that now, etc. Whatever. The code will be on GitHub later. It's actually already on GitHub, but it will be updated on GitHub later. And yeah, so if we'll we'll wait for a couple minutes. Otherwise, I'm just gonna end the meeting and assume no one has questions. All right, perfect. Everyone left. All right, I'm gonna end the meeting. Just a very quick meeting on Discord.